Hi folks, welcome back to this third video in a crash course in counting. In the first two videos we looked at fundamental counting principle and factorial notation. Like all the videos, you can find the notes both filled in and blank in the video description below, and they'll also have some practice questions in them. Today we're looking at questions like this. From a group of 10 people, how many ways can you line up 7 of them? So you could say, oh, I've got my first person and I've got 10 choices. And I've got my second person, and I've got 9 choices. And third person, I've got 8 choices. And fourth person, I have 7 choices. And so on. So fifth person, I have 6 choices. Sixth person, I have 5 choices. And seventh person, I have 4 choices. Oh my gosh. So it's almost factorial, hey? But it has to stop. It's like factorial that stops at 4. 4 multiplies all the way down to 4. Okay, so you could work this out as a number. But what you might be interested in is how can I make it stop at 4? And one way that you could do it would be like this. You could say it's 10 factorial divided by 3 factorial. And that's because 10 factorial is 10 times 9 times 8 times 7 times 6 all the way down. And 3 factorial is 3 times 2 times 1. So you can see that some things are going to cancel out here. The ones are not really that important. But we get a slightly more elegant expression for the same thing. Now, where do these numbers come from in the question? Well, the 10 is the number of people or number of objects. The 3, where does 3 come from if we have the numbers 10 and 7? It's number of people minus number we're using. And so if we generalize from this, if we had n people, how many ways can you line up r of them? So n people, how many ways to line up r of them? It would be the same kind of idea. We'd have n factorial, and we'd have the difference between the number we're using and the total number on the bottom. This is total number of possible arrangements or lineups. Possible arrangements. And because order matters, we call this a permutation, which is what we're going to get at today. Okay. A permutation is an arrangement of objects like a lineup where order matters. And there's going to be a formula for finding what the possible number of arrangements is. There's also going to be a shortcut in our calculator. So back to the notes. Permutations. A permutation is an arrangement of objects. In a permutation, the order of the objects matters. So phone numbers are good arrangements of permutations. The order matters. If you dial 1, 2, 3, 4, 5, 6, 7, it corresponds to a different number than 7, 6, 5, 4, 3, 2, 1. Often we use the word combination in sort of general language differently than we use it in mathematics. So if you have a combination lock on your locker, it's really a permutation lock. The order in which you input the code matters. If your combination is 12, 32, 17, and you put it in the wrong order, it won't open. Order matters. Your calculator can figure out the number of possible permutations that exist for a group of objects. And this expression, NPR, is going to tell us the possible number of permutations of n objects total, taken r at a time. So n is like the total number of people. R is the number that you can actually use. And I'm going to show you the formula that is used there. And we actually derived it already. It's n factorial over n minus r factorial. Okay. So it's different from simply finding an n factorial because we don't have to use all of the objects. We were kind of secretly in the last one probably finding permutations, but it was the case of using every object. So how many ways can you line up 4 books on a bookshelf if you have 9 to choose from? Okay. So we have 9 objects. That's sort of our n. and we're going to take 4 at a time. So this means the expression is 9p4, or sometimes we think of it as 9, and we're going to pick 4 of them. If I use this formula over here, that would mean I'd have 9 factorial over n minus r, so n is 9, r is 4, so over 9 minus 4 factorial. So 9 factorial over 5 factorial. And we can work that through in a calculator. 9 factorial over 5 factorial is 3024. Another way you could do this is to say, all right, well, I've got that first one I'm going to pick. I have 9 possibilities. For the second one, I have 8 possibilities. Third one, I have 7. And fourth one, I have 6 possibilities. And if you multiply those numbers together, you're also going to get 3024. And it's not a whole lot slicker to use permutations here, but it is sort of a bit of a shortcut on the fundamental counting principle. All this stuff is coming from the fundamental counting principle, though. Now, what is slick, though, is to use just the permutation button on your calculator. The permutation button will be in a different place depending on your calculator. For me, it's under Math, PRB. And you can see number 2 there is NPR. So I need to tell it 9P4. You may have to type the 9 before choosing this. And then just hit enter or equals, and it will just work it out for you. All scientific calculators should have an NPR button. So that's pretty slick. There are 3024 ways to line up 4 books from a set of 9 different books. How many 3-letter permutations are there of the word math power? So let's see, how many letters do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 objects total. We're going to take 3 at a time. That means we want 9p3. And I can do it with the formula, but it's probably faster just to type 9p3 in my calculator. Here we go. 9p3 gives me 504. This is not the only way you could do this, right? You could still use fundamental counting principle if you wanted. 9 times 8 times 7. It's going to give you the same answer. But the bigger the number of objects we take, the more helpful using this permutation method will be. So that brings us to the end of the instruction on this. There are some questions over here, just using your factorial button, and then some that are more sort of in context. And of course, there are answers at the end of the handout. This is all in the video description below for the PDFs. And it says permutation questions. Those are the ones. I hope this has been helpful. Good luck with the material, folks, and take care.